calculate the value of this one, this part. Since it is 1 and we find the base is 5, that means it should be equal to 5. So that log of 5 to the base 5, that will be equal to, as per formula 1. To avoid these fractions 1/3 and half, we multiply all by the LCM of these two denominators, which is 6. In the last class, I mentioned that in the next class, that means today, I shall work out few more sums on logarithms. Already I have written down 3 sums on the board. Good morning to all the viewers. Good morning to all students who follow my classes. Welcome to btosacademy. Welcome to my maths class. I am continuing today the topic logarithm. Now I am going to work out sums serially. I shall start from left hand side and reach right hand side. Bases are 2, 2, then 4, 2, 5, 6 plus 2 log of 2 to the base root 2. First of all, we note 256 is there. We on the right side first find the factors of 256. Already we know 256 is equal to 16 square, that is 4 square whole square, that is 4 to the power 4. As base is 4, we keep this value of 256. Log of base 2, log base 2, log of 4 to the power 4 to the base 4. In place of 256, I have written 4 to the power 4 plus, here I apply base changing formula like this: numerator log 2, denominator log of root 2. As formula, log of a to the base b equal to log a by log b. I have used here this formula, log of a to the base b is equal to, in the fraction form, where numerator is log a, denominator is log b. Already I deduced that formula in the earlier class. I have written here like this. Then log base 2, log base 2. Now log power form, 4 log of 4 to the base 4 plus 2 into log 2. This is root 2 means log 2 to the power half. Therefore, as per this formula, log, say, x to the power a to the base a will be equal to log n log of x to the base a. I suggest students or learners, while you are working out sums on specific topic, better you write the results or formula you need on the right side of the page, or you can write those initially and do the sums. Therefore, it will be, now these log 2's are cancelled. Log 4 to the base 4, log of a to the base a, I write here, log a to the base a is 1. Already we have proved. And one thing you must remember, these results. Therefore, log 4 to the base 4 will be 1. Finally, we get here 4 into 1, that is 4. Now 4 can be written as base is 2. We write it. The 4 is written like this, 2 square plus 2, half is there at the denominator. Therefore, finally it will 2 into 2, that means 4. We write on the right side. Now 2 square, log of 2 square to the base 2. This power will be taken in front as per this formula. Therefore, log of 2 log 2 to the base 2. You can skip this step also. Therefore, log of 2 to the base 2 plus 4, log of 2 to the base 2, that is 1 plus 4, that is RHS part, proved. Try to understand. First of all, this number has been expressed in the form of 4 or power of 4 like this. Then we have applied this formula and move on. Finally, we get 1 plus 4, that is equal to 5, RHS part. Hence, sum number 1 is solved. Now to solve sum number 2, I have this. LHS log of a to the base b cube into log of b to the base c cube into log of c to the base a cube. Now I apply first the base changing formula like this. Log of a log of b cube log of b log of c cube log of c log of a cube. Already I have discussed was base changing formula. Log of a to the base b, that will be equal to log a by log b. According to that formula, we have expressed each of these terms like this. Then we have log of b cube. Power is there 3, therefore it will be 3 log b, numerator log a, into 3 log c, numerator log b, into log c, 3 log a. Now we see log a cancelled from numerator denominator, log b cancelled from numerator denominator, log c also cancelled. Therefore, 45 1 by 3 cube, that is 1 by 27 RHS root. In many cases, if you use the base changing formula, the sum will be easier. Now we have worked out two sums. Then sum number 3. Followers or students already have copied this one. I repeatedly mentioned that students or learners, while you follow maths classes, YouTube classes rather, always you take a coffee and a pen first. Then you start working out with the teacher. Now, number 3. LHS 1 by log of xyz to the base xy plus 1 by log of xyz to the base yz plus 1 by log of xyz to the base zx. Already I have mentioned in the earlier sum, first we change the base like this. It will be log of xyz by log xy. Denominator of the denominator is log of xy. Therefore, log of xy will be taken at the numerator. That means log of xy, log of xyz. I write here. Since log of xyz xy is equal to 1 by log of xyz by log of xy. Now 1 by this expression, therefore that will be, first term will be 1 by log of xyz by log xy. Now log of xy is the denominator of the denominator, therefore this will be log of xy by log xyz. I have used this one. Plus log of xyz log of yz plus log of zx log of xyz. We find all denominators same. Therefore, addition as per the law of addition of fraction, LCM of the denominators, here it will be xyz, log of xyz, numerator will be log of xy plus log of yz plus log of zx. Now, already we know the formula log of a plus log of b, that is equal to log ab. We shall apply now that. log of xy yz zx log of xyz. We have applied here log a plus log b log of eb. Now what is the product? X square y square z square log of x square y square z square divided by log of xyz. This is log of xyz whole square by log of xyz to log of xyz by log of xyz. These two cancelled, therefore finally we get 2. I think students have understood. In the first step, I have used the base changing formula, then these steps followed. Therefore, we have worked out first 3 sums today. Now, second set, 4 sums I will work out. Number 1, log of this one, that will be equal to 1. For solving that, first of all, I calculate the value of this one, this part. Since it is 1 and we find the base is 5, that means it should be equal to 5. So that log of 5 to the base 5, that will be equal to, as per formula 1, let we are calculating the value of root over 5 into under square root symbol root 5, again square root 5 to infinity. Squaring x square equal to 1 square root sign, that is outmost 1 will be removed. Now this one again product to infinity, that means this becomes 5x. As I have taken x equal to under square root symbol 5 into under square root symbol 5 into under square root symbol 5 up to infinity. Therefore, after squaring, we get 5 into again this part, that is x. Therefore, x square minus 5x is equal to 0. Now taking x common factor, x minus 5 equal to 0. From it, we can conclude either x equal to 0 or x minus 5 is equal to 0. From it, we get x equal to 5. Now, x cannot be 0 as square root of some positive numbers. Therefore, x is never 0. Follow that. Square root of 5 into again square root 5 into again square root 5 up to infinity. Therefore, square root of a positive number, that can never be 0. But x is positive, therefore is equal to 5. We have got the value of this part. Therefore, left hand side is equal to log of 5 to the base 5 to the base 5, that is equal to 1 RHS proved. Very interesting one. I think you have followed. Why x is not equal to 0? I have explained that. First of all, this one is a positive number. Square root of 5 into square root of 5 into square root of 5 up to infinity. Therefore, square root of a positive number. Therefore, value of x is never 0. Now number 2. LHS log of 1 plus 2 plus 3. Now what is the sum? 1 plus 2 plus 3. Sum is 6. Now 6 can be written as 1 into 2 into 3. Now I apply the formula log of AB is equal to log of A plus log of B. Log 1 plus log 2 plus log 3, that is RHS. I think students, learners have followed. Now I am going to work out sum number 3. Left hand side log A whole square minus log B whole square, that is of the form p square minus q square. Therefore it is equal to log A plus log B whole into log A minus log B. P plus q into p minus q form, as it is p square minus q square. Now as per formula this will be log of AB into log of A by B. This is product formula. Also we can call sum formula, conversion. Then log of A by log of A by B. Now this is the RHS part. This question may be asked like this. You express this expression as a product of two logarithms. You see, this is one logarithm, this is one logarithm. Therefore, the question may be asked like this. You express this as a product of two logarithms. Then you are to follow these steps. Now, I have taken one sum for calculation. First of all, I shall calculate log of 16 by 15, log of 25 by 24, log of 81 by 80 separately. Actually, if we write the whole, that will be a larger one. To avoid that, we calculate these three quantities separately first. Number 4. Now, log of 16 by 15. I apply this changing formula. Log 16 minus log 15, that is equal to log of 16 means 2 to the power 4 minus log 3 into 5, 15 equal to 3 into 5, it will be 4 log 2 minus log 3 within brackets log 3 plus log 5. I remove the brackets and write it directly, this one. Then log of 25, 24, log of 25, log of 25 minus log of 24, that is equal to log of 5 square minus log of 24 means 8 into 3, that means 2 cube into 3. Therefore, this will be 2 log 5 minus log of 2 cube plus log of 3. That means it will be 3 log 2 minus log 3. I have calculated mentally. First of all, log of within brackets 2 cube plus 3, that is equal to log of 2 cube plus log of 3. Now, if we remove the brackets, it will be, since there is minus sign before the bracket start, therefore it will be this. Then log of 81 by 80, log of 81 minus log of 80. Now 81 is 3 to the power 4 minus log 16 into 5, 80 is equal to 16 into 5. Therefore, I can write it 2 to the power 4 into 5. That means 4 log 3 minus 4 log 2 minus log 5. To avoid the complication, I have calculated these three logarithms first, like this. Though it will be longer apparently, but it will be quite easier. Now, I put these values here. LHS is this 1 log 2 plus 16 into, already we have calculated those, 4 log 2 minus log 3 minus log 5 plus 12 log, this one already 2 log 5 minus 3 log 2 minus log 3 plus 7 into this, 7 into this one, 4 log 3 minus 4 log 2 minus log 5. Now let us simplify. Log 2 plus 64 log 2 minus 16 log 3 minus 16 log 5 24 log 5 minus 36 log 2 minus 12 log 3 plus 28 log 3 minus 28 log 2 minus 7 log 5. Now we see 64 log 2. First we consider log 2. Log 2, here is log 2 and here is log 2. 36 minus 28 minus 36 minus 28, that means minus 64. Therefore, these are cancelled. Then we consider log 3 term. 16 log 3 minus 12 log 3, that means minus 28 log 3, then plus 28 log 3. Therefore, these are cancelled. Then 16 log 5 negative minus 7 log 5, that means in this step we get log 2 plus 24 log 5 and these two minus 23 log 5, so that log 2 plus log 5 24 log 5 minus 23 log 5 log 5, therefore this is log of 2 into 5 that is equal to log of 10. Now what will be the value of log of 10? I have not discussed that matter. Actually in algebra, if there is no base, that means base is not mentioned, in that case base will be 10, that is called common base. Therefore it is log of 10 to the base 10, that means value is 1. Therefore value of this one is 1, that is RHS part proved. Now I have mentioned here base. When it is not mentioned in case of algebra, base will be taken as 10, which is called common logarithm or common base. When the base is 10, we call it common logarithm. This is introduced by John Brick, that is why we call Gregorian logarithm also common logarithm. Now I discuss this matter, basis of logarithm. First of all, common base, which is 10. Generally in case of algebra, if base is not mentioned, the base of the concerned logarithm will be 10. Then there we have natural logarithm, in that case base is e. base is E, which is Eulerian constant. Already students of 11, 12 have heard this. Base is E and its value is, it is an irrational number. It was discovered by Euler or Euler, and it is, already I have mentioned, irrational number. Generally, in case of calculus, derivative, integration, etc., the base of the logarithm will be E, and if the base be different from E, then we have to change the base using the base changing formula. Actually, all formulae or results in calculus have been formed with the help of the base E. In case of logarithm, I repeated it, in case of logarithm used in calculus, base will be E. This is called natural logarithm. And now we move to work out few more sums. I was discussing the topic logarithm. I shall continue today also working out many sums. Already I have written 6 sums on the board and I am going to work out one by one. First of all, number 1, given log of x plus y by 5 is equal to half log x plus log y. This is y. Or log of x plus y by 5 is equal to log x plus log y means log of xy half, that means it will be log of xy to the power half. Now already I have stated, if log m is equal to log n, of course m n greater than 1, then we conclude m equal to n. Therefore we can write here x plus y by 5 is equal to xy whole to the power half means root over xy squaring x plus y whole square is equal to 25 xy. This is x square plus y square plus 2xy is equal to 25 xy, or x square plus y square is equal to, we take this 2xy on the right, that is equal to 23 xy. Now we have to find the value, or we have to show this one. Therefore, if I divide both sides by xy, then this is x square by xy plus y square by xy is equal to 23. By distributive law of division we get this step, then on simplification we get x by y plus y by x is equal to 23. Already I have told the followers or the students or the learners, you take your pen and copy and start working out as I am doing. I think you have followed this one. Next, I will work out sum number 2. Number 2, given log a by b plus b by a plus 2 to the base 10 is equal to log of 4 to the base 10. Therefore, this expression is equal to 4 a by b plus b by a plus 2 is equal to 4. Now I simplify this part. ab a square plus b square is equal to 4. Take 2 on the right, that means 2. Then a square plus b square is equal to 2ab, or I take on the left a square minus 2ab plus b square equal to 0, or this is perfect square, a minus b whole square equal to 0, from which we get a equal to b. Therefore, relation between a and b is a equal to b. Relation between a and b. Thus, sum number 2 is solved. Now I move to sum number 3. For that, this is to be rubbed. Now sum number 3, x, y, z are given. We have to prove this relation. First I copy the values of x, y, z. Given x is equal to log of a to the base 2a, y is equal to log of 2a to the base 3a, and z equal to log of 3a to the base 4a. One thing, it is better you put first brackets log of 2a. Sometimes students write log just 2a without giving brackets. Sometimes that may be confusing, that is why use brackets. Now x, y, z, first of all we follow x, y. Therefore, x, y will be equal to log of a to the base 2a into log of 2a to the base 3a. Now we get base changing formula, which will be equal to log of a to the base 3a. Therefore, x, y, z will be log of a to the base 3a into log of 3a to the base 4a. Again base changing formula. Therefore, it will be log of a to the base 4a. Now, I can use again the base changing formula log a log of 4a. That means log a log 4 plus log a. Or we can calculate 2yz separately. Okay, I keep this step here. Now 2yz, that is equal to 2 into log of 2a to the base 3a into log of 3a to the base 4a. Now again we get base changing formula. Therefore, it will be 2 log of 2a to the base 4a. Better I rub this one and calculate left hand expression. Therefore, xyz plus 1 will be log of a to the base 4a plus in place of 1 we can write log of 4a to the base 4a. Therefore, it will be log of a into 4a to the base 4a. That is equal to, this is 4a square log of 2a whole square to the base 4a. Now it becomes log of a to the power n, that is equal to n log a. That is why it will be 2 log of 2a to the base 4a. Now we see both right side are equal. Therefore, x, y, z plus 1 equal to 2yz. Proved. We have just expressed x, y, z plus 1 in terms of a rather. Also 2yz in terms of a, and we find both are equal. Therefore, the problem is solved. Next, sum number 4. We have to show log of 3 to the base 2 greater than log of 2 to the base 3. No need of writing anything here. Already we know 3 greater than 2. Therefore, log of 3, I can write this one, log of 3 to the base 2 greater than 1. Right side is expressed in the index form 2 to the power 1. Also, taking log of both sides, log 3 greater than log 2, also 2 to the power 1 is less than 3, we can write log of 3 to the base 2. Here base is 2, therefore we can express this one like this. If we take log of right side, that will be log of 2 to the power 1, that is 1 into log 2 to the base 2, which is 1. Also, 2 less than 3, and this is 3 to the power 1. Therefore, log of 2 to the base 3 is equal to is less than, inequality relation will hold, less than log of 3 to the base 3. You can write like this also. Therefore, log of 2 to the base 3 is less than 1. This is greater than 1, this is less than 1. Therefore, from 1 and 2, log of 2 to the base 3 less than log of 3 to the base 2. We can rewrite this one, log of 3 to the base 2 greater than log of 2 to the base 3. Hence it is proved. Now number 5. We have to prove this one. We write like this: to show 1/3 less than log of 3 to the base 10 less than half. To avoid these fractions 1/3 and half, we multiply all by the LCM of these two denominators, which is 6. Therefore, 6 into 1/3 less than 6 into log of 3 to the base 10 is less than 6 into half. When you get inequality, if we multiply both sides by a positive number, then the relation will hold. Therefore, we can do this. Therefore, 2 less than log of, now I can take this as index of 3. Now, finally, we have to show this one. For that, we see the base is here 10. Now, 3 to the power 6, 81 into 9, 7 to 9, and 10 square, 10 cube. As base is 10, also you can think like this: 2 log of 10 to the base 10 log of 100 to the base 10. These two can be written as this one, and 3 can be written as 3 into log of 10 to the base 10, that is log of 1000 to the base 10. Now 1000, 100, 729 are there. As 100 is less than 729, and that is less than 1000. Therefore, now I express these two as power of 10. 10 square is less than, and this is as 3 to the power 6 power of 3, and this is 10 cube. Now I take log of each, taking log of each, base of course 10, what we get? Log of 10 square to the base 10, log of 3 to the power 6 to the base 10, log of 10 cube to the base 10, and from that 2 log of 10 to the base 10, that means 2 less than 6 log of 3 to the base 10 less than 3. Therefore, one by 3 less than log of 3 to the base 10 less than half. I repeat, to prove this one, as there are fractions, we first remove those fractions by multiplying by the LCM of the two denominators 3 and 2, that is 6. We get integers, natural numbers. Next, 2 can be written as log of 100 to the base 10, and 3 can be written as log of 1000 to the base 10. This is 1000. Now, 3 to the power 6 is there. On calculation, we get 3 to the power 6 is equal to 729. Now, 729 lies in between 100 and 1000. Therefore, we follow this way. Thus, sum number 4 is solved. Next, sum number 5. Sum number 5 is solved. Sum number 6. Sum number 6. Given log of 2 to the base 10, that is equal to p. We have to find the value of this one. Now, log of 2 to the base 20, using base changing formula, we write 1 by log of 20 to the base 2, and that is equal to 1 by log of 20 can be written as this one, that is equal to 1 by log of 2 to the base 2 plus log of 10 to the base 2. Therefore, log of 2 to the base 20 is equal to 1 by log of 2 to the base 2 means 1, and log of 10 to the base 2. We have given log of 2 to the base 10. Using base changing formula, we can write log of 2 to the base 10. Therefore, this will be equal to 1 by 1 plus 1 by p. Now we simplify this one. The denominator is p, 1 plus p. Therefore, this is p by 1 plus p. Therefore, log of 2 to the base 20 is equal to p by 1 plus p. Answer. Thus, we work out first 6 sums. Next, I will work out more sums.